let's start lecture 6. So lecture 6 is about statistical analysis. It's actually statistical analysis spans from EDA. When we do the exploration of data, we can use statistics to explore the data. We can also analyze using some statistical techniques, and finally we can predict, doing the predictive analytics using statistical techniques also. Okay, so it spans many things. That's why I highlight this statistical analysis should belong to both the second step, acquire and prepare, and also the third step, which is analyze and interpret. So this is today's outline. We will talk first about correlation analysis, and then we will go to trend line forecasting, and then we will be done with hypothesis testing. So when we talk about statistics, okay, there are two major areas of statistics, which is the first one is descriptive statistics. This go along with descriptive analytics, because we try to describe the properties of the data. But according to statistics, we have sample data and population data. So these are two different things. But in descriptive statistics, that goes along with descriptive analytics, we focus on those statistical measures like central tendency, the mean, average, right, mode, median, variability, variance, standard deviation, the distribution of the sample data. That's what we talked about before. Inferential statistics is another major area, which is in inferential statistics, we try to inference. That means from a big data from the population, we try to draw some conclusion about it. But since we don't have those big data, the population data on hand, we only have sample. So what we can do is that from the sample, we try to study the characteristic in the sample and try to make inference for the conclusion of the population. ก็คือมีแค่ sample แต่เราอยากจะรู้ว่า population เป็นยังไง เราก็ใช้แค่จาก sample นี่แหละใช้หลักการทางสถิติตัวนี้ที่เรียกว่า inferential statistics ในการสรุปเนาะว่าถ้ามี sample แบบนี้แล้ว sample หน้าตาประมาณนี้สรุปว่า population ก็คือประชากรทั้งหมดก็น่าจะประมาณนี้ด้วยนะคะ so that means in inferential statistics we try to make the things called generalization, just like when we do machine learning, right? We try to generalize the machine learning model. So we try to generalize about the large groups. We try to, for example, estimate the demand of the product, but we don't have all the surveys of all the people who try the product. We can only sample some of the consumers that have already used the product, and then we can use that to predict some future events. So this prediction will also belongs to this area of inferential statistics. So when we talk about population and samples, we say population are the entire population, means entire objects, right? All people in Thailand who have the right to vote, for example, all people in Bangkok who use this product. Okay, sample means set of objects that are selected, that we hope that they can be the representative of the whole population. For example, we interview some consumer who use our product, or we interview for the survey. So the role of the samples means it helps us to draw some conclusion that we cannot do with the complete surveys. We cannot ask every people, right? We cannot ask 60 million people, right? So we can only ask, for example, if we do poll for election, we can do just like 30,000 or 5,000 people. So statistic of inferential statistics will make us infer about population from this sample, but we need to rely on some assumption. that assumption is that the sample must be selected randomly from the population, not bias. Okay. So first thing about what we talk about is to try to find the correlation between two variables, right? Two variables. We talked before when we explore data that we usually use descriptive statistics, right, to try to explain each variable, right? But we also want to explore the things called relationships between a couple of variables. And one thing that we can do to try to explain them is to come up with these numbers called correlation coefficient. And there are many variants of correlation coefficient. The one that we mostly talk about is Pearson's correlation coefficient. ภาษาไทยก็จะเรียกว่าสัมประสิทธิ์สหสัมพันธ์เนาะ Pearson นะคะภาษาไทยเนาะสัมประสิทธิ์ก็มาจากคำว่า coefficient สัมประสิทธิ์สหสัมพันธ์ก็คือ correlation Pearson อันนี้เป็นชื่อคนนะชื่อนักวิทยาศาสตร์นักสถิติซึ่งPearson correlation coefficient is the most classic coefficient when we talk about correlation. So if anyone come to you and say, this correlation is 0.8, they usually mean Pearson correlation coefficient, this one. Okay. So it is a parametric. You may learn in statistical course before, right? Parametric, not parametric. Parametric means we have some assumption, and the assumption of using Pearson correlation of coefficient is that we assume variables are normally distributed, and that's why it's called parametric. Okay. And one thing is that the Pearson correlation coefficient is sensitive to outliers, just like the average, the mean, the geometric mean, right? It's also sensitive to outliers. That means if we have outliers, it may skew the number, the measure. ก็คือถ้ามันมี outlier ก็จะทำให้ค่า correlation coefficient เนี่ยมันหลุดกับค่าของข้อมูลส่วนใหญ่จริงๆนะคะเหมือนค่ามีนเนี่ยถ้าเกิดมี outlier ค่ามากเนี่ยมันก็จะทำให้ค่ามีนเนี่ยมันเยอะกว่าความเป็นจริงที่ควรจะเป็นอันนี้ก็เหมือนกันนะคะ and one thing is also Pearson correlation coefficient measure linear correlation. What does it mean by linear correlation? It means that if one variable increase, let's say twice, right? Another variable also have twice more of that values of the values of the second variables. So this means under the assumption of normal distribution. No? Okay, so let's see. When we talk about relationship, we remember the diagram that we choose the graph, right? We will usually choose scatter plot. So we use scatter plot to explain the correlation between two variables, maybe x and y. And if we found that the scatter plot looks something like this, right? That means if x increase, y also increase too. If x decrease, right? X decrease like this, y also decrease too. Okay, this means it is positive correlated. Okay, and the opposite is so-called negative correlated. If x increase, y tends to decrease. Right? If x decrease, y tend to increase to the opposite direction. What about this one? Half of them increase, half of them decrease. Okay, so maybe this is quite ambiguous. If you try to come up with a measure, that means you try to come up with the Pearson correlation coefficient, you will find that maybe it will report not correlated. Okay. And if you have scatter plot that looks like this, that means they are obviously uncorrelated. Correlation coefficient should be around 0. Okay. Okay, so correlation, it describes the strength of the association or relationship between two variables, whether it depends on whether it's linear or non-linear. Okay, but what you need to know is that when you interpret เมื่อเราแปลคำว่า correlation it does not mean causation ก็คือ correlation หมายความว่าเป็นเหตุเป็นผล cause and effect means เป็นเหตุเป็นผลเนาะง่ายๆตัวอย่าง on the right hand side we have sunburn แพ้แดดอาการแพ้แดดสมมติไปเก็บข้อมูลคนแพ้แดด and ice cream sales นะคะปรากฏว่า what we get usually will be high correlation between these two numbers sunburn numbers and ice cream sales numbers but does that mean sunburn make ice cream sales higher? No, right? Not likely related in that way, right? But the numbers goes together in high positive correlation. Why? Because we have the third variable. In this case, it should be hot weather. Because hot weather cause sunburn, right? A lot of sunshine, right? Hot weather cause ice cream sale. It's hot. We need to eat some ice cream, okay? So that means this hot weather third variable is called confounding variable. ถ้าแปลภาษาไทยก็อาจจะเป็นตัวแปรที่ทำให้ยุ่งเหยิงก็คือมันไม่ได้หมายความว่า sunburn ไป cause หรือทำให้เกิดไอ้นี่หรือไอ้นี่ทำให้เกิดไอ้นี่นะคะแต่เป็นตัวนี้มากกว่าที่ทำให้เกิด2ตัวนี้แล้วมันก็เลยไปด้วยกันเป็นเวลามันหาค่า correlation coefficient นะคะดังนั้นต้องระวัง you need to beware about interpreting this correlation coefficient. Do not try to say oh this cause this cause this. No, the correlation coefficient itself doesn't tell you like that. But if you want to try the cause and effect, you need to use another statistic technique. So it's called factor analysis. It's more complicated about that. We don't talk about that. Okay. So, but some pair of variables actually have cause and effect. For example, if I try to have the number of study at home, right, and the score of the test score, you will find that it goes along together. High correlation coefficient and also usually it is a cause and effect, right? The one who study a lot usually get high test score. Okay, so it drives, right? But just want to know that the correlation coefficient, the number itself doesn't tell you. It may tell you if you have some background knowledge or some domain knowledge about it. Okay, so in Excel we can use the formula correl, and then your input is two set of variables, and there's no option to choose which correlation coefficient. This is only Pearson correlation or coefficient between two numerical arrays. Okay, so this correlation coefficient range from -1 to +1. So if it's close to +1, it means it is highly positive correlated. The same, if it's close to -1, it's highly negative correlated. If it's close to 0, it means this is no correlation or very weak correlation. So someone asked me whether how can I judge the number in the correlation coefficient. Is it 0.8? Is it high enough? No, there's no actually standard for that. Okay, you can actually have some judge using your own knowledge, or you can just compare between two numbers that oh this is 0.8, this is 0.6, this 0.8 is stronger than the 0.6, and that's it. But of course there's some people who try to set the standard on the number. Let's say if it's like 0.8 up, it means very strong correlation already. It's positive or negative, it depends. If it's about 0.4, 0.5, it may be like called moderate correlation. If it's below 0.4, it should be called weak correlation, something like this. Okay, you may already seen it. And so this is for fun. If you try to look at this scatter plot and correlate with the numbers of correlation coefficient, you will find that if you get a 1 correlation coefficient, it could be like this, it could be this, or this, or this. So it doesn't tell you the slope of the relationship. Okay, it only tells you that it goes along together. It may goes along twice, or it may goes along just one time, something like this. Okay, let's now take a look at our Excel. Okay, so I've already plot the graph for you. Let's say we want to find the correlation coefficient for sales versus profit. Okay, so Corel. We will use structure reference again. Okay, so this sheet is called orders between sales and orders profit. Okay, so correlation between A and B and B and A are the same. So you can whatever do order sale, order profit, or order profit, order sale, it should be the same thing. Okay, so we get 0.48. Okay, so what does it mean, 0.48? Let's say it's about average, right? It's about moderate, not average, moderate. So let's say I use AI to help me. Okay, it says moderate positive correlation. What is the interpretation? It means that we have some link that is meaningful, that higher sales with the higher profit, right? Which is quite a fact. Higher sales should be higher profit, right? But it's not 1-to-1. It doesn't mean sales twice more will get profit twice more, right? Because what? Because there are some other factors. For example, cost. For example, delivery margin. For example, profit margin. For example, if we have discount that should eat up all the profit, just like what we have seen before with Superstore. Okay. So now let's do the other two, which is the quantity profit and discount profit. Okay, so I will give you 2 minutes, okay, to come up with the correlation coefficient of these two pairs. Okay, so 155, 157, then okay, what's your result? Okay, let's see whether you're same as mine. Okay, So Corel orders quantity, right? And then orders profit. Okay, this is very small number. 0.06 is almost 0, right? And this one, Corel orders discount, and oh, it's negative correlated but very weak, right? Minus 0.21. So let's see the interpretation. Okay, so this this one, this pair, you can see from the scatter plot that it's uncorrelated, because the higher the quantity doesn't mean higher profit, right? Small quantity can give you a higher profit or very low loss, higher loss. It could be two ways, right? So that means it's goes along with the correlation coefficient that's close to 0. Okay, so interpretation from AI says moving more unit does not guarantee, okay, more profit. Okay, so wait a minute, I have some people. Okay, let's continue. Okay, so moving more unit does not guarantee you more profit. So sales more doesn't mean it gives you more profit. Okay, you need to take a look, what did you sell? If you sell things that have high profit margin, then of course you will get more profit. But if you sell more of the things that you don't get profit margin, why do you sell it? You sell more doesn't mean it will give you more profit. Okay, between discount and profit, okay, this one is already in our hypothesis whether discount will make profit less, higher discount, right? So it looks like it has this small relationship, right? Weak to moderate negative correlation, minus 0.21. As this count increase like this, you can see that as this count is high, you usually lost, right? Profit negative means you lost. And if you didn't give high discount, you give small discount, you likely get more profit. Okay, so suggest that maybe the cost of the discount is not offset by the profit margin. So it seems that this discount might not be profitable and should be reconsidered about it. Okay. Next, you can see that we have 3 or 4 variables here, and if you want to find correlation coefficient using the formula, you need to do pair by pair, right? But actually in data analysis, we have a tool, that is the analysis tool pack that we use to generate a descriptive statistic. Before that, we can do all those pairs once and it will give us all the pairs like this. This is called analysis tool pack, the correlation. Okay, so let's go to the analysis tool pack. I think you have used it before, so go to data and the data analysis here. Okay, and then choose correlation, and then okay, and then input range. So you have 4 numerical attributes, which are sales, quantity, discount, profit. We can do all 4 together at once. Okay, so we can choose R to U like this. Okay, R to U. In columns, right, we have labels in first row. Yes, so tick the label labeled in first row. And then the output range, okay, we can choose like just new, not need to be new worksheet. Let's say we put it here for ease of comparing, okay, and then just click OK. It should be just 2 seconds, okay, yeah. And this is what we get, right? So on the diagonal and the attribute itself, it should be 1, right? And this is between quantity and sales. This is between profit and sales. So the same number over here, okay? This is quantity and profit. This is discount and profit. Okay? So the same with the formula or with the analysis 2-pack. Okay, so if you're done with this, just type 1. Okay. Okay, now let's take a look at what AI give me. Okay, I let them conclude about what we get from all the pairs. So between sales and profit, of course, this is moderate, and it usually, like a fact, revenue is the best driver for profit. Okay. Sales and quantity, 0.2 is a weak positive correlation, so volume does not equal to revenue. That's what we already talked about. Sales discount, minus almost 0, right? So discount doesn't significantly have relationship with sales, okay? Profit and discount, okay, this means that discount will hurt your margins. Quantity and discount, this is almost 0 again. That means discount does not have anything to do with volume, okay? So this is what I want to let you take a look, what AI told us. Beware what I told you before, that correlation coefficient doesn't mean causation. Look at what AI told us. It used the words drive, driver, right? Drive or effect. So this is the words for cause and effect. I said before that when you interpret correlation coefficient, you should not have the interpretation of cause and effect. However, if you add them up with all the background knowledge and domain knowledge, you may be able to come up with something like this. โอเค ก็คือครูกำลังจะบอกว่าถึงแม้ว่าครูจะบอกว่าเราไม่สามารถใช้คำว่าอันนี้ทำให้เกิดอันนี้ได้ด้วยค่า correlation coefficient อย่างเดียวนะคะซึ่ง AI เนี่ยมันพยายามใช้คำพวกที่เป็น cause and effect มาให้อันนี้เราต้องระวังมากๆเลยอะไรที่มัน return จาก AI อย่าไปเชื่อ 100% นะคะกำลังจะบอกว่าถ้าดูจาก correlation coefficient เพียวๆอธิบายนี้ไม่ถูกนะคะแต่ with background knowledge ด้วยความรู้ทั่วๆไปแล้วใช่ไหมว่า sale and profit มันต้องคือเซลล์เยอะมันก็จะทำให้ profit เยอะเนี่ยมันได้เป็นความรู้ทั่วไปอยู่แล้วอะไรอย่างเงี้ยนะคะเราอาจจะใส่คำพวกนี้ลงไปได้ด้วยความหมายที่มาจาก background knowledge เสริมเข้าไปใน correlation coefficient แค่มาช่วยในการ confirm ตัวเลขพวกนี้เท่านั้นเองนะคะเพียงแต่ correlation coefficient ตัวมันเองไม่ได้พูดอันนี้ต้องระวังนะคะ okay. So now it's your turn. I have another sheet of data. Okay, so let's go to sheet correlation. I have 3 sets of attributes. IQ, number of hours of TV per week. Actually, people don't watch TV anymore. I should change to games, something like that, right? Hours of TV per week, and the test score. I want to know whether there are some correlation between these variables. Okay, I want you to come up with these correlation. Actually, Pearson correlation between all the variables over here. Okay, so I will give you 3 minutes right now to 7 to 10. Okay, find me pairwise covariance coefficient between these 3 set of attributes. Okay. And then we'll try to make some inference from that. Okay, anyone finish this? Okay, I forgot to click record 5 minutes before. I'm sorry about that. Okay, so let's do this. How about this too? Okay, insert scatter plot. Okay, and then these two. Okay, insert scatter plot. Okay, all right. This is between IQ and hours per week, and then add axis title. Okay, this is IQ, so equal IQs. This is hours TVs per week. Okay, let's change the title so that we know which one is which. So this is IQ versus hours TV per week. This is IQ versus test score, and this is hours TV per week versus test score. Okay, so add the axis title. Okay, this is hours TV per week, and this is test score, right? Okay, let's see. I adjust this a little bit. Okay, let's say it's already full, although I'm like a perfectionist. Okay, so if you are with me here, just type 2. So let's see what happened. You can see that, okay, this is 0 point, this pair, right? These two variables are correlated, really high correlated, positive correlated, 0.8, right? 0.8. So you can see that it goes like this, right? So it looks like the high IQ comes with high test score, low IQ comes with low test score, except there's a little bit of the outlier here. This point, these 2 points, looks like a small outlier, not much. So that makes it not perfect one because of possibly these two points. Okay. This IQ and hours of TV per week minus, right, almost 0. Why? Actually, there are outliers here too. This point and this point looks like outliers to me. It's actually this. Okay, it's actually like this, which means high IQ usually watch less hours TV. Low IQ actually watch more, right? So it could be more minus, but since it has obvious outlier, so it skew the correlation coefficient, because as we have discussed before, Pearson's correlation coefficient is sensitive to outliers. Okay. How about this one? This one is minus, right? So it looks like this. It looks like this. Our TV per week, more. Test score, less. Our TV is less, test score, more, right? But also a little bit outlier over here too, right? Over here a little bit. This looks not an outlier, but off a little bit, right? So it is not high negative correlation coefficient because of these outliers, possibly. Okay. And okay, now what other choice do we have if we want to not make the correlation coefficient less sensitive to outliers? We have another options called Spearman rank correlation coefficient. So Spearman rank correlation coefficient is a non-parametric. It means that we don't have the other assumption that says our data needs to be normally distributed anymore. Okay, so it also tests correlation the same as Pearson correlation coefficient, which means one increase, another increase or decrease. Okay, so it's actually Pearson correlation on rank, not on the raw value of data, but on the rank of the data. So try to come up with some appropriateness between these two. You can see that Pearson might be appropriate for data with interval or ratio scale, okay, with numerical value, while Spearman is more appropriate for data with ordinal scale, with order, but not fixed. Okay, so you can use Pearson correlation. You can use Spearman rank correlation for interval and ratio scale. Just that you need to convert those interval and ratio scale into rank. Rank mean order ก็คือเปลี่ยนเป็นแทนที่จะเป็นค่าจริงๆเปลี่ยนเป็นลำดับมัน Let's see that in a few minutes. How do we do that? Okay. Another correlation coefficient is called Kendall-Tau. Kendall-Tau is more like Spearman rank, but it's more appropriate for the rank that are tied. ก็คือลำดับบางทีมันเท่ากันก็จะเป็นลำดับเดียวกันเยอะๆอย่างเงี้ยจะใช้ Kendall-Tau ค่อนข้างจะเหมาะกว่า okay. Now let's see how do we convert from raw values to ranks. We can use Excel by using rank.average. Okay, so how do we do that? Rank.average, for example, this is A2 and this is A2 to A11. You want to know whether 106 is at which rank compared to all the data that we have, right? And the third parameter is whether you want ascending or descending. Ascending is 1, descending is 0. You can just choose the same thing and that's it. Okay, so how can we get this? What does it mean? It means that the rank 1 of IQ goes with rank 1 of TV hours. Let's see how it happened. So what is rank 1 in IQ? What is the lowest number of IQ? Here, 86, right? So if I sort IQ, we get 86. What's next? 97, 98, 99, 100, 101, 103, and so on, right? So this is rank 1, this is 2, this is 3, this is 4, this is 5. Okay. How about TV hours? Rank 1 is 0, right? 0, and then 6, 7, 17, 12, 17, 20, and so on, right? So this is rank 1, this is 2, this is 3, this is 4, 5, 6. You can see that rank 1 of IQ goes with rank 1 of TV hours, so we get this pair. Rank 2 of IQ, which is 97, goes with 20, which is rank 6. So we get this to go with 6. This is how we come up with these rank numbers instead of the raw data values. Okay. Once we get the ranks, we can just use Pearson correlation coefficient to get the coefficient numbers, and that number doesn't call Pearson anymore. It's called Spearman's rank, because we convert to rank first, and then from rank we find the Pearson correlation coefficient. Okay. So the difference between Spearman and Pearson can be seen in some of the cases here. So Spearman does not assume the relationship is linear. For example, if we have data like this, you can see that it goes along very well. If x is high, y is also high. If x is low, y is also low. But Pearson only gives you 0.88 y because it's not linear. It's not like this, right? It's not linear. At the end of both, it looks like it's more than linear. It's probably exponential. Okay, so it goes up more than the linear one. Okay, if you use Spearman, you will get a very perfect positive 1 correlation coefficient because it goes along very well. Why don't it get 1, right? So the Spearman is very useful if the assumption is not linear. Okay. Another case, if data are normally distributed without any outliers, usually Spearman and Pearson will be quite similar or have really small difference, just like this. This is like a normally distributed data, and so Pearson give you 0.37, Spearman give you 0.35, so almost the same. Okay. What if we have outliers like this? These are outliers. Without outliers, these are quite a perfect, almost perfect positive correlated, right? But Pearson correlation only gives you 0.67. Instead, Spearman gives you 0.84, which is very high. So should we use this or this? This looks more like the one that we should interpret, because these are just outliers. We may need not to consider these data points at all. Okay, so Spearman makes sense in this case. That's why we say that Spearman is less sensitive to outliers if compared to Pearson correlation coefficient. Okay, so now let's make Spearman rank for our TV hours and IQ. So can we do that? First, we convert to rank. Okay, let me copy the label here, and then I will input the formula rank dot average. Okay, so I want to know 106 A2 compared to the whole set of data A2 to A11, and then I type F4 so that I will make it fixed, and then I can choose descending or ascending, just need to be all the same thing. So let's say ascending. Okay. Alright, and then just copy. Okay, apply all the things. So 100 means rank 4. Okay, 86 rank 1. Okay, do the same with another 2 variables. So rank dot average B2 to B11, and then 1. Right, so drag down the formula. Same here, rank average. This, and then 1. So you can see that for test score there are 0.5. Why? Because there are many numbers that are the same, just like this, 7 and 7, 6 and 6. So when you have the same number, this is rank average, right? So rank average means if you have the same number, it will average. So two numbers, the same thing, you will average using 0.5. Okay, once you get this, I will give you 3 more minutes to come up with the Spearman ranks. So you don't need to do anything, you can just use Pearson correlation coefficient using analysis toolpack to come up with a table like this, but from this ranked data. Okay, so to 35, then to 38. Okay. So for those who finish, do you see the difference between Pearson's correlation coefficient and Spearman's ranks? Where are the difference? Okay, let's see what I have here. I can just go to the data analysis, correlation, and then instead of A1 to C11, it is F1 to H11 for mine. Okay, I want output range to be here, right? And okay, and it's quick because our data is very small. Okay, what do we get? Comparing between these two. Okay, let's see. For the higher one first, between IQ and test score, you can see, right? 0.79 becomes 0.76. So this is actually quite very small difference. I would say it's actually not different. Okay, what about this? Okay, IQ and RTV. Spearman is a lot higher, negative, right? Minus 0.17. This is almost 0. Okay, so what does it mean? This, you can see that we have noticed before that these points, these data points might be outliers, and if we don't consider these 2 points, probably we get negative correlation coefficient here. So it reflects in Spearman's rank with higher negative correlation coefficient. So it tries to avoid these 2 data for us already. But since these are not that perfect negative, okay, so we didn't get very high negative correlation coefficient here. What about this minus 3.3T and minus 0.29 is actually not quite different. Okay, so we don't have any large outlier over here. We only have a little bit here, right? But it still goes along with the negative over here, so that's why it doesn't actually have much difference between these two, Spearman and Pearson. Right? If anyone finished this, just type 3. Okay, so now this is what we got here. Let's move on a little bit before we take a short break. So From relationship that we get from correlation coefficient, we want to move to prediction. So this will be considered as maybe predictive analytics. Okay, we talk about using trend line and forecast. So trend line could be separate, like in English, trend and line, or it can be together. This trend line together is like a specific keyword in Excel. Trend line is also named line of best fit. It could be a straight line, or it could be a curved line in a chart that shows the pattern or the direction of your data points. So trend line can be added in Excel in a variety of Excel charts. Of course, scatter plot, but you can also add trend line in bubble plot, in stock plot, in 2D bar, 2D column chart, array chart, or even line chart. Okay. This is able to, but I didn't mean that it should. Okay. Usually you will add trend line mostly on scatter and probably bubble, but not some others. Probably a little bit. Some people also add in column, but I don't recommend that. Okay, so you already finished your statistic course and also data science course and even machine learning course, so you know what trend line is. Behind the trend line is actually, what is it? Regression, right? Regression using least square method, right, to fit the data points to trend line. Right? So in Excel, we have choice. Right? The default is the linear one. Right? For the linear, that means y and x is linear. Y equals x plus b. But we can also choose other types of trend line: exponential, logarithmic, polynomial. So exponential is e to the something, right? Logarithmic is ln or log, the same. Right? Polynomial is different degrees of polynomials, right? And power is x to the power of b. And another is moving average, so you can have the average of the set of points moving. Okay, so if you are interested in choosing trend line, you can go to this URL. Okay, but in here configuration, you can just freely choose based on your assumption, based on your background knowledge. The thing is that you should take a look at the equation on the chart and the R square together. So what does it mean by R square? R square is the measure of the goodness of the fit. So that means R square measure how good is your trend line, how good is your line that you fit with the data. Does it fit or does it not fit? Okay, the name of the R square can be called coefficient of determination. So someone see, oh, coefficient, is it the same as correlation coefficient? No, it's not the same. Why? Why it's not the same? Correlation coefficient tells you about the relationships lie beneath the variables. Right? R square tells you that given your data points, if you come up with this line, how good is this line as compared to the data points that you try to fit? So R square is like the quality measure of your line, but correlation coefficient is like a property of your data ใช่ไหมก็คือไม่เหมือนกันนะคือค่า R square บางคนเข้าใจว่าคือค่าเดียวกัน R square correlation coefficient คนละค่ากัน correlation coefficient คือเป็นเหมือนค่าที่ได้จากการดูความสัมพันธ์ระหว่าง2ตัวแปรนะคะไม่ได้มีเกี่ยวอะไรกับเส้นเลยนะแค่เอา2ตัวแปรมาดูส่วน R square คือจาก2ตัวแปรแล้วคุณสร้างเส้นขึ้นมาไอ้เส้นเนี้ยมันดีขนาดไหนมันฟิตกับ Data ไหมแต่ก็โอเคแหละเข้าใจผิดได้เพราะอะไรเพราะว่าโดยปกติ2ค่านี้มันมักจะไปด้วยกันก็คือถ้าตัวแปร2ตัวแปรมันมี correlation coefficient ที่สูงปุ๊บเนี่ยมันจะฟิต Data ออกมาได้ง่ายมันจะออกมาเป็นลายได้ง่ายแล้วไอ้ลายนั้นเนี่ยมันก็จะมี R square ที่สูงไปด้วย ก็เลยทำให้คนบางคนเนี่ยเข้าใจผิดเนาะนะแต่จริงๆแล้วไม่ใช่ค่าเดียวกัน r square จะหาได้ก็ต่อเมื่อมี line มาฟิตนะคะอยู่ดีๆมีตัวแปร2ตัวแปรแล้วจะถามว่า r square เท่าไหร่อันนี้ไม่ใช่นะนี่คือ correlation coefficient นะคะ so r square measure อะไร measure proportion นะสัดส่วน of the variance between dependent variable y whether it is predictable from the variable x using this trend line นะ so it range usually from 0% to 100%. If r square is 1 or 100%, it means that the trend line fit perfectly with the data, just like in this small picture here. You can see that small picture here. You have a straight line here with all the data points on your line, so it fits nicely. How can it make r square 1? Because let's look at the formula of r square. How can you come up with r square? R square is 1 minus sum square residual divided by total sum square. What is this two numbers? ครูอธิบายเป็นภาษาไทยจะได้เข้าใจง่าย total sum square เนี่ยไม่ได้ขึ้นกับตัวเส้น total sum square เนี่ยคำนวณมาจากอะไรมันคือ sum square difference between actual data point and the mean ก็คือเอาค่า y มาหาค่า mean แล้วดูว่าจุดข้อมูลเนี่ยค่า y ของจุดข้อมูลห่างจากค่า mean นี้เท่าไหร่เราจะเรียกค่านี้ว่าเอามายกกำลัง2แล้วบวกกันเราจะเรียกว่า total sum of square ก็คือมันเป็นตัวบอกว่าค่าจริงเนี่ยมันห่างจากค่าเฉลี่ยค่า y เนาะเท่าไหร่ไม่เกี่ยวกับเส้นเลยเนาะเพราะฉะนั้น total sum square หาได้โดยที่ไม่มีเส้นนะคะแต่พอมีเส้นแล้วจะหาตัวนี้ได้ sum square residual เพราะ sum square residual คือหาว่าพอมีเส้นนี้มาเนี่ยมันมี error ที่เกิดขึ้นจากค่า y จริงกับค่า y ที่อยู่บนเส้นของค่า x นั้นๆเนี่ยเท่าไหร่ถ้ามันห่างเยอะเช่นแบบนี้ห่างเยอะเลย error ตัวนี้ก็จะเยอะเห็นไหมเพราะฉะนั้นมาดูสูตร r square มันเอา sum square residual หารด้วย total sum square ดังนั้น r square จะเป็นจะเป็น1เท่าที when will r square becomes 1 when this become 0 ก็คือ no error at all no sum square residual error there will always be total sum of square error because it's the deviation from the average คือค่า total sum square ยังไงต้องมีมันไม่ใช่0แน่ๆหาร0ก็ไม่ได้อยู่แล้วเพราะว่าอะไรเพราะว่ามันต้องมีความห่างจากค่าเฉลี่ยอยู่แล้วเนาะอันนี้หาจากค่าแต่ทั้งหมดนี้จะเป็น0ก็ต่อเมื่อข้างบนเป็น0ก็คือไม่ห่างจากเส้นเลยก็คือเนี่ยเหมือนตัวอันเนี้ยไม่ห่างจากเส้นเลยก็คือข้างบนเนี่ยเป็น0ก็0ก็กลายเป็น0พอเป็น0ก็คือ1ลบ0ก็คือ1แล้วค่าจะเป็น0เมื่อไหร่ r square when it becomes 0ก็คืออันนี้เป็น1ถูกปะจะเป็น1ก็เมื่อไหร่อ่ะก็เมื่อ sum of square residual เนี่ย equals to total sum square ก็คือเป็น1เมื่อ error ที่เกิดจากการฟิตเส้นเนี่ยเท่ากับ error ที่เกิดจากค่าเฉลี่ยเลยก็จะได้หารเท่ากันตัดกันตัวนี้ก็จะเป็น1 so my question is can r square be minus can be negative or not yes or no can r square be negative yes or no yes or no can r square be negative r square เป็นติดลบได้ไหมอย่าไปเชื่อสไลด์ครูอาจจะบอกไม่หมดใช่ปะ is it can r square be negative when will r square be negative take a look at the formula when will the r square be negative is it possible to be negative it can be negative if this portion is higher than 1 right when it is when the sum square residual is larger than total sum square is it possible to be larger than total sum square of course นึกสภาพจุดคุณอยู่ดวงจันทร์ใช่ไหมเส้นคุณอยู่ตรงเนี้ยจุดคุณอยู่ดวงจันทร์ error ตรงนี้เป็นไงเยอะมากถูกป่ะเพราะฉะนั้นพอ error ตรงนี้เยอะมาก sum square ratio คือขนาดใหญ่มากๆส่วนด้วย total sum square หารจากค่าเฉลี่ยก็อาจจะประมาณหนึ่งอ่ะงั้นข้างบนใหญ่กว่าข้างล่างเยอะมากเป็นไงตัวเลขมันก็จะแบบเลขเยอะเลยเอา1มาลบมันก็จะกลายเป็นติดลบเยอะๆถูกไหมคะเพราะฉะนั้น r square can be negative but usually we will not see that but it's possible it means that if r square negative means you don't need to fit data คือจะทำไปทำไมถ้า r square ออกมาเป็นติดลบเนี่ยคือจะทำไปทำไมก็ใช้ค่า average แทนสิ you can just use average if you use average your r square will be 0 right so if you try to use trend line to forecast or predict something and you get r square negative you just waste it คือทำไปเสียเวลาเปล่าๆว่างั้นเถอะถ้าได้ r square เป็นติดลบก็คือจะไปใช้ทำไมก็ใช้ทำนายว่าเป็นค่าเฉลี่ยก็จบละได้ r square 0ดีกว่านะคะเพราะฉะนั้นติดลบได้เพียงแต่โอกาสจะไม่ค่อยเห็นเท่านั้นเองแต่ไม่ใช่ไม่เป็นไปไม่ได้โอเคทีนี้สรุปง่ายๆ conclusion r square is the quality measure of your line okay so let's come up with that line okay how can we do that here we can just add the element trend line here see trend line okay but if you want to see the parameter the equation of this line and the r square you need to go to options so you can go to more options here or you can just double click the line to open up the configuration here right once you open up the configuration you can enable this tool display equation on chart and display r square value on chart okay it will report you here you can move okay so right now with this line right linear equation is 0.1452x minus 6.9167 you get a y okay given an x you input to the equation you get the y this is the y on this line this is the trend line and this trend line quality measure is 0.62 very good it's very good 60 it can that means this line can explain about 62% of the variance of the data points okay you can if you want to try other types of trend line you can change it here let's say exponential oh you get a little bit more r square or logarithmic right polynomial you can just keep changing okay this getting better okay but you don't just change for fun okay actually choose based on background knowledge you don't just choose for fun sometimes r square doesn't tell everything okay sometimes you will have some background knowledge let's say I have background knowledge about IQ and test score it goes linear so I will just choose linear over here okay so once we get this right with the 10 line I can come up with my question for example let's say if I want to know that okay my daughter let's say I have a daughter my daughter IQ is 100 can you predict how much test score do she have of course with this trend line I can tell you right so let's say my daughter IQ is 100 okay and let's say I want to predict her test score okay I just use this equation 0.14 times 100 and then minus 6.9167. Okay, what do I get? I get 7.6033. Okay, this is the prediction or forecasting of my daughter's test score if she has 100 IQ. Right? So it means that this line gives you some inference about your data in the future, right? Unknown data that you may come up with. Okay, so now it's almost 3. I have some work for you to do during your break. Okay, I want to have 2 more trend lines for these 2 pairs of variables. Okay, let's try to choose which one you think it's possible, it's suitable for these 2 pair of relationships. Okay, and then we'll come back and let's see together what I choose and what you choose. Okay, so it's 3, right? So let's say 315. Okay, add trend lines for this and then we come up to see what happens.ต่อนะคะ Okay, so let's take a look at if I add 10 line over here. Okay, and then I go to config the trend line, more options. Okay, and then display equations and a square. Okay. For this, which one do I choose? Let's say exponential? No? Linear. Oops, what happened? It doesn't go along with what? Again. This one. Let me go back. It looks like it doesn't sync. So this trend line. Oh, there's 2 trend line. I see. Why there's 2 trend line? Remove one. Trend line number 1. Okay, I have 2 trend line. Why do I have 2 trend line? Okay. Display equation. Okay. Trend line. Okay. Exponential. Again. Okay. Linear. Okay. Why doesn't it follow? It looks like my Excel does have some problem. Let's see. I remove this. It's still okay when I use it at home. So let's remove all of them. Just okay. And then I add new 10 line. I get more options. Okay. I display equation. Let's see if I change to exponential. Does it change to exponential? Linear. What happens? Let's see. I remove this. How about this? logarithmic. It doesn't look like logarithmic for me. Oh, maybe the display. Alright, maybe this before the display. Okay, this looks like polynomials to me. Okay, logarithmic. This look okay. Linear, exponential. Okay, so it looks to me that polynomial does make sense, because 2 degrees of polynomial, so we have x squared plus x. Okay, so let's see if I choose this one. Right. Okay, I choose polynomial one. Okay, what about yours? Okay, let's see again. If my daughter have 100 IQ, so how many hours of TV per week she will use? Let's see. If it's minus to 0.35 times twice, or you can use power, plus 278 times 100 minus 1322.8. Okay, 29. Okay, so if my daughter IQ is 100, she should use about 29 hours of TV per week. So 29 is here, right? It's around here, right? Here, okay? Alright, so the next one, I will add, let's move my display. I will add trend line, and then more options, display equations. Okay, so this is negative, right? Negative. Okay, linear. Okay, let's see, exponential. Not better. Not better. A little bit better. You can choose polynomial or you can choose linear. I think it's not. It's quite low anyway. So R squared doesn't. So we cannot fit just the trend line for this. Probably we may be able to come up with something better if we try some other orders, the degree of orders like polynomial, 3 degree of order, 4 degree of orders, probably we will get. Okay, let's say we choose linear. So that means if hours of TV per week decrease to 50 twice, for example, test score will decrease about will increase about how much? Not much, just not 0.5, something like that. Okay, so let's do like this. Okay, if anyone is with me, just type 4. Okay, next, what do we do next? In Excel, there is a forecast function. a few variants of forecast, but usually in this class we will use forecast.linear only. There are some other 4 exponential smoothing forecasts called 4 ETS functions. Okay, we will talk about ETS or exponential smoothing later on when we do Tableau. Okay, so we will, let's say we will assume that we will do linear forecast. So linear forecast, behind that the mechanism is the same as fitting linear trend line. So they use linear regression and the least square method to fit, right? But Excel forecast function just don't draw the trend line for you, okay? But the result will be the same thing. Okay, what do you need to give to forecast? Or forecast is the old version, so right now for the new version they force you to use forecast.linear. Okay, so you give it an X, you try to come up with the Y with the forecast, the regression. So you need to give it the known Y and known X. So these are all the requirements for the forecast function. Now let's see, we want to forecast. Let's first do this couple, IQ versus test score. This is what we already have, right? Pearson correlation, Spearman correlation. We already try to come up from the equation that we get if I have IQ 100. Okay, let's say if I use forecast. Okay. Forecast equals forecast dot linear. Okay, X is 100. Let's say known Y is test score, right? So known Y is here, F4. Known X is IQ, okay, F4, right? Forecast linear, I want to know if X is 100 here, if I know my Y, which is all the test score I have in my data points, and all the X I have in my data points, A2 to A11, can they regress and then come up with the resulting predicted Y for me? So in this case, yes, 7.60, almost the same, right? 6033 and 6078. Why the difference? A little bit different, because actually this equation from the trend line is not, has already been rounded up, right? Actually it's 0.1452 something, and that something is not reflected here, so that's why it's a little bit of the rounding things that make it different over here. Okay, same. Let's see the result for this forecast dot linear. Okay, if I'm 100, my X, my known Y, all of TV per week. Okay, my known X, IQ, right? IQ. Okay. Okay, what do I get? I get something different. Oops, is it? Oh, okay. Am I correct? It doesn't look like I got something correct. Known X, IQ, known Y out of TV per week. Oh, correct. Okay. Oh, why? Did I do anything? What's yours? What happened? C2 F2 N1Y. Oh, I chose the wrong one, right? It should be the raw data, not the spearmint rank data. Okay. Sorry. This should be known Y here. Okay, sorry. Known X is here. Okay. Okay, 20. Sorry about that. So why it's quite different for this case? Because these are two equations. This is polynomial, right? This is polynomial, degree of 2, right? This is linear. That's why. So if you use a linear, you get some line like this. Therefore, if IQ minus IQ 100, you will get around 20 test score. Hours for TV per week here. Okay, that's why the difference between these two numbers. Okay. So in this case, you get 20 versus 29 from polynomial. Okay, if you're done here, just type 5. Alright, now let's move on to our last topic today, which is hypothesis testing. I think you already know that in your statistical course, right? When we talk about hypothesis testing, we first need to come up with hypothesis to test, right? So a hypothesis in data analytics means something that is testable. So we want to know that this relationship is actually right there in your data or not, right? So it can help us to maybe guide for the entire analysis or the analysis later, or we can use hypothesis testing to prove the results of our machine learning. Then someone's asked whether you should use hypothesis testing for every machine learning, because if you use Python before, right, some machine learning algorithm actually return p-value, which is part of the hypothesis testing for you. Question is, do you need to take a look at that? Answer is, it depends. If you are more of the statistical guy and you want to have the testimonial that say, oh, this my machine learning is statistically significant, something like this, yes, you may need to take a look at the p-value. If not, just like us who are more practical one, it may not be actually that important for statistical testing with the machine learning algorithm, because someone says that, okay, what you use with the machine learning algorithm is you try to predict the future things which haven't known. So how can you test, right, the things that you don't know before, right? It's not the same as the inferential statistic, where you want to come up with something that explain population that you already have, that present in the real world, but you just cannot have the opportunity or the budget to survey all of them, right? But it's right there, it's already right there. But for machine learning, it's the future, it's the future thing, it's something that you are not known, right? Or it doesn't happen yet, so it's something that might be considered as different. Okay, so you don't need to listen to me much. Okay, everything actually needs change. Actually, everything changed. So let's see whether we should look at hypothesis testing or not. But okay, come back to our content. Okay, hypothesis testing means we try to transform the raw data into some goal-oriented or structured investigation to lead to some conclusion rather than just assumption. So the basic idea of the hypothesis testing is that we want to make some decision about the value in the population parameter, okay, but we don't know the true parameter, that is unknown, but it's already there, the true value is already there, but it's behind the population things, and therefore we need to make some hypothesis of what that value of that true value should be, okay, and want to test whether it is, okay. So the classic example of teaching hypothesis testing is drug testing, okay. This all come from I got it from George Stramer. If you search for something or statistic in YouTube, you will find that it will suggest you George Stramer YouTube channel. He's very funny. He's very good at explaining statistics things. Okay. So usually drug tests. Let's say I have some headache. Drug A and B, and actually I want to sell. I sell A. I want to claim that my drug A is better than drug B, for example. So what do? I ask person to test, right? Person who get headache to test my drug. So let's say I have some money, and then I ask 3 persons to who have a headache right now, and then test my drug, and then ask them how many hours they use to recover after taking the drug. So let's say person 1 says 10 hours, person 2 says 22 hours, person 3 says maybe 18 hours. So this is the amount of time that it takes to recover. Maybe person number 1 is very healthy, so it takes less for her or him to recover from the headache. Okay. Now I want to compare with drug B. Okay. The same. I ask 3 more persons, and these 3 persons have a headache and take drug B, and they report us how many hours again. So person 4 about 28 hours, person 5 20, person 6 26 or 27, right? So these 3 looks like it's time to recover for drug B a lot more than drug A. So usually what do we conclude? We usually use average, right? So let's say the average time to recover for drug A is about how much? 15 or 16. Okay. The average hours for drug B is about 30 or 31. Okay. That means on average there is about 15-hour difference between drug A and drug B. So let's see how do we come up with the hypothesis. From these numbers, I can come up with one hypothesis. Let's say, okay, people taking drug A need on average 15 fewer hours to recover than drug B. That means drug A is 15 hours better. Okay, I can sell drug A now. Is that it? I can now claim that my drug A is better than drug B right away. How can you make, let's say, investor to be more confident on this, that your drug A is better? Right now, drug A looks better, but if we repeat the experiment, right? So to make investor more confident, let's say this second experiment has the result that are totally different. Now, drug B is actually better. What? Drug B is actually better? Let's say this is 35 hours better. Oh, why? What happened? Right? So the first experiment and second experiment are actually conflict. How can it be? It can be because maybe they don't control the experiment. Maybe in the second experiment, people who take drug B actually were super healthy, eat healthy food, have exercise every day. Or maybe person who take drug A in the second experiment is very stressful, right? So it takes more time to be recovered. Or even worse, maybe we just mislabel the drugs. Drug A become drug B become drug A, like something like this, right? So what do we do next? How do we make investor invest in our drug A? With these two experiments seems not enough, right? So we need to come up with more money and try to recruit more people to do more experiments. Let's say that the other experiments all follow the second experiment or doom. That means why? That means when we keep repeating experiment, that every time it was conflicted with the first hypothesis. So how can we conclude this? Do we say the hypothesis is wrong? No, we don't say it like that. We don't say hypothesis is right or hypothesis is wrong in statistical testing. What do we say? We say is that we can now have a lot of experiments, right? That means we are more confident, right? We can confidently reject the hypothesis because the data with the more experiment show strong evidence that it's the opposite. It's not what we already come up with in the first thing. So we don't say it's wrong. We say we want to reject that hypothesis. Okay, so keep up the keywords reject. Okay, now let's do another pair of drugs, drug C, drug D. Okay, first we found that we got 13-hour difference between drug C and drug D. So drug C is better. So drug C on average 13 fewer hours to recover than people taking drug D. Okay. Now again, we want investor to be confident, so we recruit more. Okay, we do two more experiments, and these two repeating experiments actually show the same direction with the hypothesis, but that same direction has slightly different numbers due to some random things that might happen. So we get 12 hours difference, we get 13.5 hour difference, right? So how come? What should we do now? It looks like our hypothesis is correct but not completely correct. It's on the same line, it's the same direction with the hypothesis, but it's not 13 hours, right? It's not exactly 13 hours every time that we did the experiment. So we are not that confident about the numbers, but we are quite confident of the direction. So because of this, usually we don't say the hypothesis is correct. We will say that the hypothesis is fail to reject the hypothesis. So you only have two choices, reject or fail to reject. Okay. Summarize. To do hypothesis testing, you need to come up with hypothesis. Then you do experiment, you get the data, and that data will be evidence. Whether your evidence is strong enough to say the hypothesis is wrong, but you don't say like that. You say you reject the hypothesis, or the data is quite similar to hypothesis but not exactly the same. You will say you fail to reject the hypothesis. Okay. So get back to the number. Is it 13 hours, 12.5 or 13.5 or 13.25 when we come up with the hypothesis at the first time? Remember, the goal is that we want to claim the difference between drug C and drug D, or drug A and drug B, right? Actually, we want to sell drug C, for example. We want just to claim that drug C is better. Okay, how much better? We may not need to claim that. So people usually come up with some general hypothesis, says there is no difference in recovery times between drug C and drug D. Why no difference? Because usually we want to start with hypothesis that is the opposite of what we want to conclude. Why? Because if we can conclude, that means we can reject. If we have strong evidence, then we can reject the hypothesis to be there is difference, right? ก็คือเวลาเราตั้ง hypothesis เรามักจะตั้งตรงกันข้ามกับสิ่งที่เราอยากจะสรุป เพราะว่าอะไร เพราะถ้าเราตั้งตรงกันข้ามแล้วเนี่ยแล้วเรา reject ได้ การ reject ได้คือมี strong evidence ในการ reject นะคะ การที่ reject ไม่ได้ก็คือเราไม่มี strong evidence จริงๆแล้วมันอาจจะ reject ได้ก็ได้แต่ว่าเรายังหา evidence ไม่เยอะพอก็เป็นไปได้นะคะ This is like when we talk about you go to court and then court tells you that you are not guilty, right? You may be guilty, but they don't just have evidence enough to tell you are guilty, right? So in the court, they only have guilty and not guilty. There's no right and wrong in the court, right? So the judge will not tell you you are wrong, or the judge will not tell you you are right, right? They will say you are guilty or not guilty, depends on the evidence. Yeah? The same as hypothesis testing. So in order to make hypothesis to be quite general enough, right? We call this null hypothesis. So null hypothesis is H0. Usually it will be quite general. There is no difference. No difference means different in this case in mean. So mu C equals mu D, or you can change to mu C log mu D equal to 0. The same thing. ก็คือ mu ก็คือค่าเฉลี่ยของ population ใช่ไหม So we do not need to worry about how much the difference is. This is called null hypothesis. The mean difference can be any value in this case. But without null hypothesis, we need preliminary data to tell us how much difference, right? Just like drug A and drug B, we need to come up with experiment first, and that experiment need money. We need some budget, right? So people usually come up with hypothesis without first experiment, without primary data, without preliminary data. So we can have that as null hypothesis. And then once we have null hypothesis, we go to do experiment and get the data to convince that we want to reject or we cannot reject. That means we fail to reject. ถ้า we reject ได้ก็คือ there is difference นั่นเองนะคะ Okay, so statistical test is that we want to decide whether we reject or fail to reject an hypothesis by running through statistical test. So statistical test needs three things: 1. Data. 2. Null hypothesis that we can reject or fail to reject. 3. Alternative HA alternative hypothesis, which are usually the opposite of the null hypothesis. But it might be more complicated for 3 groups or more, because if you have 2 groups, right, this is no different. The opposite is there is difference between A and B, right? But if you have 3 groups, no different and different will have more than 2 things, right? For example, if it's different, is it A and B different than C, but A and B is equal, or B and C equal and different from A? So if you have more than 2 groups of sample data, then the alternative hypothesis is more complicated. Okay, right now we don't talk about that. Okay, so alternative hypothesis is, in this case, there is a difference in recovery time between drug C and drug D. So mu C not equals to mu D, or we're gonna write mu C minus mu D not equal to 0. Okay. Now, when we do hypothesis testing, there are 4 scenarios that could happen. Okay, let's see whether we reject or we fail to reject, right? And whether the alternative is true. This is the real thing, no? This is the real thing. Or null hypothesis is actually true. So let's look at the correct scenario first. If we reject hypothesis and the alternative hypothesis is actually true, that means we reject it correctly, right? So this is the correct version. Okay. Another case, if we fail to reject the null hypothesis, but the null hypothesis is true, so this is fail to reject is correct, right? Now let's look at the incorrect scenarios. The first scenario is the test reject null hypothesis, but actually you should not reject because the null hypothesis is true. In this case, it's called type 1 error เนาะก็คือจริงๆแล้วเรา reject แต่ดันจริงไม่ควร reject อันเนี้ย reject ผิดนะคะ Another case is different, right? That means you fail to reject but actually you should reject เพราะว่า alternative hypothesis มัน true นะคะก็คือควรจะต้อง reject แต่ดันไม่ reject อย่างเงี้ยเรียกว่า type 2 error ทีนี้we will call the probability of making type 1 error as alpha. The probability of making type 2 error as beta. But usually we will not touch the beta one because they says that the beta one, the type 2 error, cannot be set in advance, and it depends on the real true value which is unknown in the population over there. Okay, so usually we will look at alpha. Alpha is the probability of making type 1 error, or it is called level of the significance of the test. ก็คือนัยสำคัญของตัว test นั่นเองก็คือค่าอัลฟาตัวนี้ค่าอัลฟาตัวนี้พูดง่ายๆภาษาไทยก็คือเหมือนกับความเสี่ยงที่รับได้ the risk that you can afford to making incorrect conclusion นะคะว่า alternative is true when in fact actually null hypothesis is true ก็คือการเกิด type 1 error นั่นเองนะคะก็คือเหมือนกับว่าค่าอัลฟาเนี่ยคือค่าที่เราต้องเซตเพื่อบอกว่าเฮ้ยจริงๆแล้วเรารับ error ตัวนี้ได้ประมาณเท่าไหร่จริงๆเราอยากได้0แหละerror ตัวนี้อยากได้เป็น0แต่มันในความเป็นจริงมันเป็นไปไม่ได้แล้วเรารับได้เท่าไหร่ถ้างานเป็นงานที่ serious like medical test อย่างเงี้ย usually alpha will be small เพราะว่าเรารับได้น้อยงานที่เกี่ยวข้องกับชีวิตคนเราไม่ควรมี error เยอะอัลฟาก็อาจจะเซตเป็น 0.01 ก็คือ 1% แต่ถ้าเป็นงานที่แบบอิเล็กเคขางานเกี่ยวกับ entertainment อะไรอย่างเงี้ยเนาะ digital marketing อะไรพวกเนี้ยก็อาจจะเซตไว้สูงก็ได้ 10% 0.1 ก็ได้ก็ไม่ซีเรียสรับได้ผิดพลาดรับได้ไม่เสียหายอะไรมากนะคะแต่โดยปกติถ้าไม่คิดมากเขาเซตอัลฟาเป็น 0.05 นะคะทีนี้ how to make decision to reject or fail to reject the null hypothesis this will be based on what number so my question is which metric that we will be using to reject or fail to reject this metric needs to come after we do experiments so this is called p-value p-value in Thai โอกาสที่จะสรุปผิด p-value will come from the experiment not from setting alpha is from setting whether you expect you can afford คือค่า alpha เนี่ยเป็นค่าที่เราเซตไว้ก่อนว่าฉันรับได้แค่นี้นะส่วน p-value เป็นค่าจริงที่เกิดขึ้นจากการไปทำ experiment นะซึ่งก็จะอยู่ระหว่าง0กับ1 p เหมือนเป็น probability เนาะแต่มันคือโอกาสที่จะสรุปผิดนะก็คืออีกอันนึงก็คือ how confident we could be that duck A is different than duck B ยิ่ง lower p-value more confident so some statistician will just treat the p-value as the indication of strong evidence นั่นเองนะ standard practice ก็คือเรา we set the threshold in advance which is the alpha รับได้แค่นี้ alpha บอกเราว่าเราได้แค่นี้ then if we come up with experiment and p-value if this p-value is less than this threshold experiment we can say that the result is statistically significant ก็คืองานนั้นมัน sig นั่นเองมีนัยสำคัญทางสถิติก็ต่อเมื่ออะไร p-value น้อยกว่าเท่ากับค่าอัลฟาที่เราเซตเอาไว้เราถึงจะถ้าน้อยกว่าก็คือ reject null hypothesis เพราะอะไรเพราะพอน้อยกว่าก็คืออะไรมันน้อยกว่าที่เราจะรับได้ก็คือโอเคไงมี strong evidence มี strong evidence ก็คือ reject ได้นะคะดังนั้น in summary we need decision threshold alpha to be set in advance let's say usually 0.05 then we do experiments we have a hypothesis right experiment will tell me how much is p-value and we use this p-value to reject if that p-value is less than or equal to alpha if p-value greater than alpha we fail to reject okay so this is the idea of hypothesis testing but in reality there are many hundreds or thousands of hypothesis testing available depends on what you want to test so in this class we only want the simplest one which is called t-test so what is t-test t-test is a parametric test again that means we have the assumption that the population is normally distributed okay so the purpose of t-test is to compare the mean value of two groups okay whether it's different or not so on the assumption of population normally distributed okay so that means t-test for difference between sample mean you don't have population you only have sample okay ก็คือ t-test เอาไว้ test ว่า mean ของ2กลุ่มต่างกันไหมthen t-test has 3 types first type is you have the standard global value to compare this is called one sample t-test คือ one sample คือ1 sample คือ1 group of sample ไม่ใช่1คน1 group of sample เทสออกมาแล้วเปรียบเทียบกับค่า standard ค่าหนึ่งอย่างเช่นเราบอกว่า let's say the longevity of Thai people is 79 ก็คือ 79 ก็ตายอย่างนี้เนาะแล้วก็ไปเก็บข้อมูลมาว่าเป็นคนกลุ่มหนึ่งตายอยู่เท่าไหร่นะคะ then we calculate this t-test statistic นะคะ using some formula you can just go ask AI เนาะ which formula so in Excel there's no one sample t-test เพราะว่า one sample t-test เนี่ย you calculate from formula you do not calculate from statistical test per se okay so what do Excel have Excel have two things Excel have two sample t-tests or independent sample t-tests mean you have two groups of people and then you want to compare these two groups. The third type is called pair sample t-test. So pair sample t-test mean you only have one group of subject but you do twice. Say p-test, post-test, test the E20 oil กับ E95 oil ก็ use the same car right use the same car too. Let's first E20 another the same car with E95 something like this. Okay, so that is pair sample t-test. Okay, so you need to choose the correct test according to your context, according to your problem. Okay, now let's do together. We want to test whether the fertilizer is actually effective ก็คือปุ๋ย fertilizer คือปุ๋ยเนาะว่าปุ๋ย help us to extend the size of the plant สมมติปลูกผักบุ้งเนี่ยให้ผักบุ้งมันโตสูงขึ้นไหมแล้วก็เราก็ไปทำกลุ่มหนึ่งใช้ปุ๋ย fertilize one แล้วก็เก็บข้อมูลความยาวของต้นไม้ unfertilize one take note of the size of the plant and then we try to come up with the t-test to test hypothesis about the size. So our now hypothesis say mu1 equals to mu2 or mu1 minus mu2 equals to 0. That means there is no difference between the size of the trees whether fertilized or not. So the S0 means that the fertilizer is not effective. Alternative hypothesis is the difference. That means the fertilizer is effective. There is some difference, but that difference don't know how much difference, just difference between the size of the trees. Okay, so which type of this t-test it is? Why do we choose t-test? Because we want to test the mean, and we have the assumption that the population of fertilizing plants should be normal. Okay, so this is two sample t-test. Okay, so let's go to our file fertilizer. Okay, and here we have 9 samples each with fertilizer and non-fertilizer. We go to data analysis. Okay, and then we choose t-test. So there are two sample t-test, 2 sample assuming equal and unequal variance. These two are actually quite similar. You choose one will be the same because it's actually difference in how close to reality it is ก็คืออันไหนคือถ้าเลือกถูกมันจะเหมือนจริงมากขึ้นแต่ว่าผลลัพธ์ไม่น่าต่างนะคะคุณเลือกอันไหนก็น่าจะได้นะคะ Let's say if I talk about fertilize and non-fertilize, the variance should be different, right? Fertilize should be something that grows good and something that not grow good, but right? Unfertilized, unfertilized. Sometimes it grows very good, but sometimes not. But if it's fertilized, it should be good, right? So let's say I assume unequal variance, okay? And then okay. And then input 1, okay, A1 to A10, input 2, B1 to B10, and then I choose labels, right, because I have labels, column header, alpha is already set for us, right, you can change here. Hypothesize mean different, depends on your S0, so what is your S0? S0 says mu1 minus mu2 equal to 0, so hypothesize mean different is 0 here. That means if you have preliminary data just like drug A and drug B, you may put 13 hours over here if you have. So 0, okay, and then I put output over here. Okay, so how can we interpret the result? You can see that it calculate mean for you, fertilize 35 and fertilize 31. If you only look at the mean without doing hypothesis testing, you may claim that, oh, fertilizing is better. No, this is not the way for statistical significant. No, if you want to claim statistically significant, you need to do hypothesis testing. You cannot just claim from calculating mean like this. Okay, variance should be different, right? Observation the same. For 2 sample t-test, you can have different numbers of sample between 2 sample เนาะก็คือ fertilize อาจจะมี10 ต้น unfertilize อาจจะมี20 ต้นก็ได้นี่ไม่ว่ากันนะคะสามารถคำนวณได้สิ่งที่เราสนใจคือ5ค่านี้นะคะ5ค่านี้คืออะไร5ค่านี้นะคะ first we need to know whether our test is one tail or two tail test. So what's the difference between one tail and two tail test? We look at HA. If HA is unequal size, then this is two tail. Why? Because two tail mean it could be larger or smaller two size, right? ก็คือถ้าไม่เท่าคือไม่เท่าฝั่งมากหรือไม่เท่าฝั่งน้อยก็ได้ถูกไหม This is two tails. But if we have less than or greater than size, this is one tail. So in t-test, it's normal distribute like this, right? So this is t value. It's the value that we will get from the t-statistic test. And if it's around in the middle, that means the value of the two groups are not that different. So we cannot reject the hypothesis. If we need to reject, it means it's over or it's smaller, it's larger or smaller, a lot, right? A lot larger or a lot smaller. So either this side or this side. So this red area means that if your value called t-stat that you calculate from experiment is at this area or this area, that means you can reject hypothesis because this area is the area from alpha. Alpha คืออะไร risk ที่ยอมรับได้เขาจะ come up with the alpha ด้วยค่า t critical คือเขาจะแปลงค่า alpha เป็นค่า t critical ให้คุณ critical นี้ก็คือเป็น threshold เป็น decision threshold ก็คือว่าถ้าค่า t stat ที่ได้มากกว่า t critical หรือน้อยกว่าลบ critical หมายความว่าโอกาสที่จะสรุปผิดมันน้อยกว่าที่จะรับได้ก็ดีไงก็ดีคืออะไรเรามี evidence strong ที่จะ reject แต่ค่า t stat อยู่ช่วงกลางๆนี้ก็คือเฮ้ยมันไม่ได้ต่างว่ะมันค่าประมาณอยู่กลางๆเท่าอ่ะยังสรุปไม่ได้อย่างนี้เราก็จะ fail to reject hypothesis for one tail the same, it will give us t critical, and if it's over t critical or lower than minus t critical, it depends on whether it's larger or less than size นะคะก็ we can reject the null hypothesis นะคะ so in this case is it one tail or two tail? H0 no different, H1 is different, so it's two tail. Okay, this is a two tail test, so we don't need to actually take a look at one tail results at all, but Excel report all the possible one tail and two tail because Excel doesn't know our hypothesis. Excel is not AI. Excel cannot predict what are our hypotheses. So we need to choose ourselves for the results. In this case, we choose to use two-tailed test. So once we get to know two-tailed test, there are two ways to decide whether we reject or fail to reject. Either look at p-value alone, right? 0.11x5 is larger than, greater than 0.05, so we fail to reject ก็คือ 0.1185 เนี่ยมันมากกว่า 0.05 เนาะ ดังนั้นเราจะ fail to reject หรือดูผ่าน t-stat ก็ได้ we can take a look at t-stat. t-stat is 1.64, but our T critical is 2.11. What does it mean? It means T critical is 2.11, but t-stat is 1.64. It's over here, so we cannot reject, right? We fail to reject. If we get t-stat to be 2.xx, something like this, we can reject. So it will go together. คือจะดูผ่าน p value ก็ได้หรือจะดูผ่าน t critical กับ t stat ก็ได้มันต้องไปในทำนองเดียวกันอยู่แล้ว it need to be the same answer. It cannot be conflict, right? It must go along together. So in this case we fail to reject the null hypothesis. That means the observed mean difference between three size sample with and without fertilizer 35 and 31 is not convincing enough to say that the fertilizer actually influence the tree size. So the difference is not statistically significant ก็คือ not sig ไม่ sig นั่นเองไม่ sig คือถ้า fail to reject เราก็จะได้ยินคำพูดว่าการทดลองนี้ไม่ sig ไม่ sig ก็คือ reject ไม่ได้ fail to reject นะคะก็คือค่า p value เนี่ยมันมากกว่า 0.05 หรือ decision threshold ที่เซตไว้ตั้งแต่แรกนั่นเองนะคะทีนี้หน้าที่เราบ้าง I have another sheet called training program effectiveness. So for this example, imagine that we have a training program and we need to determine whether this training program is actually effective by looking at participants pre and post test score. So I have pre and post test score of participant or student, in this case 15 students, right? I want to say whether my training program is effective or not. So what do I do? First, I set alpha, right? Let's say, I don't know, I set alpha to be 0.5. Then I need to come up with H0. First, let's say H0 means there is, actually I want to say it's different, so the opposite is there is no difference between pre post test score of students, right? That means the training program is not effective. So HA is the opposite, right? HA is there is difference, right? Correct? The training program is effective. Okay, so we want to reject. If we reject, that means we try to accept นั่นแหละแต่เราไม่พูดเท่านั้นเอง accept HA ก็คือ there is difference between pre and post test นะคะโอเคเนาะนั่นคือ mu p equals mu post นะคะ Okay, so I will give you, let's say, 5 minutes to do this, and you answer me whether you reject or fail to reject. Okay. So for 12 now, for 70. Okay. Okay, let's take a look whether we reject. Now I posted it, no? Okay. Go. Which type of the t-test we choose? Which type? In this case, pair ใช่ไหม pair two sample because it's the same student. They take pre-test and then they train, right? And then they test post-test. So this is the same people. It's called pair. pair. So for pair two sample t-test, the number of subjects needs to be for input 1 and input 2 needs to be the same, otherwise it will be error. Okay. So p-test, post-test, and then hypothesis mean difference 0, no difference. Labels, yes, we have labels, and then output. Okay, let's say here, right? Okay, what do we get? So pre-test 97, post-test 107. Difference, no? But we are not sure whether it's statistically significant or not. Okay, observation the same. It reports Pearson correlation coefficient for you too. You can see that, oh, very high, not that high, moderate positive correlation between pre-test and post-test. That means if the student got high pre-test, he or she usually have high post-test. Okay. Hypothesis mean different. Okay, T-stat out. First, we need to determine whether it's one tail or two tail. So in this case, no different, and different is not equal, right? So it's two tail. So we only look at two tail. I will just highlight it here, right? We don't need to look at one tail. I will just write two. Okay. So P is very low, 0.00, just like our friend says. Right? So less than p value less than alpha 0.05. That means we reject the null hypothesis. Or we can take a look at T critical and T stat. You can see that T stat is minus 373, just like it looks like something like this, right? If we have T statistic, right? T stat is minus, and T critical is 2, how much? 2 something, right? 2.144. Okay. So 2.144, but it's on the negative side, so it must be minus 2.144. So it's in the area of here, right? So it's beyond it's what we can afford, that we wrongly make the conclusion. Okay, so we can absorb these errors because this error should be small. Okay, so in this case we reject the null hypothesis. That means the training program is actually effective. There are enough or strong evidence that post-test mean score is higher than pre-test mean score, and the difference between pre and post-test is statistically significant นั่นเองนะคะซึ่ง difference ขนาดไหนก็ไปดูค่า mean อันหนึ่ง97อีกอันหนึ่ง107ดีขึ้น10คะแนนประมาณนะคะโอเค so in conclusion what we did today is we understand the relationship using Pearson and Spearman's rank correlation coefficient. We know that Spearman is less sensitive to outliers. We also use trend lines and forecasting to help look at the future values that may come up later on. Right? We do hypothesis testing, which help us make data-driven decision. We test the null hypothesis and determine whether the data support us to reject or fail to reject. Based on t-test that we did, we know that t-test is a parametric test. It relies on the assumption about the population distributions. Okay. So in this case, we can have the project canvas fill up, right? We already have the 4 before, right? We can have 5, right? ขอเป็นภาษาไทยนะเนาะอันนี้ก็คือดูจุดคุ้มทุนใช่ไหมพิจารณาการลดราคาอย่างรุนแรงดูวิเคราะห์รวมกลุ่ม aggregate on region ระบุสินค้าที่ขาดทุนนะ drill down to products, drill down to SKU. Let's see which one is lost, right? And then we have the findings from our data that we already did with the visualization and the pivot table เนาะคุณไปดูเองแล้วกันประมาณนี้นะคะอธิบายว่า margin เกิดตอนที่เป็นยังไงบ้างเรา discount มากกว่า 20% เกิดอะไรขึ้นนะแล้วก็ recommendation and action นะก็คือปรับกลยุทธ์ห้ามให้ discount เกิน 20% ถ้าปรับกลยุทธ์อย่างนี้ได้คาดหวังว่า action ที่เกิดขึ้นเนี้ยมันจะ impact อะไรบ้างมันก็จะไป impact ตามที่เรา set objective ไว้ก็คือ profit น่าจะได้ 5% นะคะ 5% คำนวณจาก data เก่าก็น่าจะได้ประมาณ $3,000 นะคะนี่ก็คือ the complete data analytic project canvas that I also want you to come up with something like this on your project about move account นะคะ okay so we don't have more homework but we have quiz I know that some of you and some of your friends went to competition, right? So I will make the quiz to be due tomorrow before midnight. So you have 2 days, today and tomorrow, to do the quiz, right? I will just open the quiz right now, but takes time. You may not need to do today. You may, or you can do after this, right? You have time limit of 20 minutes to do your quiz, right? But once you click to do, the minutes gets count, and then you cannot do the second time. Okay, so you have until tomorrow's evening. Just you may review my video later on before you do. It's okay. It depends on yourself. Okay, so any question for now?